Hi everybody, today we're going to continue in 5.6. Instead of focusing on the quadratic formula, we're going to focus on what is called the discriminant. The discriminant is going to be the part under the radical or the square root in the quadratic formula. Which is going to be b squared minus 4ac. The reason we look at the discriminant is because it can tell us how many solutions we're going to have and what type of solutions we're going to have before we even solve the problem. So, notice here in red, it is just b squared minus 4ac. Do not worry about the radical, so you don't need the square root over top of that. We're just going to look at b squared minus 4ac. That is what we call the discriminant. So how does this work? Well, you have your quadratic equation, again, in the form ax squared plus bx plus c is equal to 0. Again, still dealing with that 0. That's how we use the quadratic formula, so we need that for the discriminant as well. So if you calculate b squared minus 4ac and it is greater than 0, then you're going to have two real solutions. Okay, so that means you're going to have numbers like 4 and 6 or whatever it ends up being. So we're just back in those regular normal numbers that you guys have worked with for forever. If it is exactly equal to 0, you're going to have exactly one solution. We went through an example in the last video where we actually ended up with our square root being 0, and we had one real solution. In that case, it was 3. So that vertex is going to sit right on the x-axis there. It's not going to intercept it at 2 points. If your square root is, or your b squared minus 4ac underneath the square root is less than 0, what you'd end up trying to do is you are going to have the square root of a negative number, so you're going to end up with two imaginary, I call them complex solutions. So you're gonna bring in the I again. So you're gonna get something like 2 plus or minus 3i would be your complex solution. So we're going to find the discriminant of each quadratic equation, and we're going to use that to tell us how many solutions we're going to have and what types of solutions we're going to have, whether they're going to be real or complex. So if we look at A, our A value, again, I do this with the discriminant as well. I list these out. B is going to be -6 and C is going to be 10. So you're going to take -6 squared minus 4 times 1 times 10, which is going to give you -6 squared is going to be 36 minus 4 times 1 times 10 is going to give me 40, so we're going to get -4. Okay? -4, if I go back to my chart, that is less than 0, so that means I'm going to have two complex solutions. B, we take a look at that. Again, A is still 1, B is still -6, and C is going to be 9. So I take a look at -6 squared minus 4 times 1 times 9. I end up with 36 minus 36, which is 0. Going back to my chart, I see that if it is equal to 0, I'm going to have one real solution. So I'm going to have one real. So, and hopefully, you know, there's not a great way to remember these. I just kind of think about it, to be honest with you. I see if I'm taking the square root of a negative number, oh, I've got to have complex solutions. If I'm adding and subtracting 0 from the same number, I'm going to have the same answer, so I'm only going to have one real solution. As you guys guessed, this one's probably going to end up with 2 real, but let's double check. A is going to be 1, B is going to be -6, and C is going to be 8. If I take -6 squared minus 4 times 1 times 8, I'm going to get 36 minus 32, which is 4. 4 is greater than 0, which means I'm going to have 2 real solutions. So I take the square root of 4. I can add and subtract 2 from the same number, and I'm going to stay in the real number system. So that means I'm going to have 2 of them because I can add 2 and I can subtract 2 in that case. So that's really how I kind of think about these. Other than that, if you're a memorizer, memorize this chart, and that'll help you out. That's all I have for you guys today. If you guys have questions, let me know. We'll practice in class, and I will see you guys next time.